Good morning, students. So after completing the exercise 8.1 from the chapter Quadrilateral, now today we have to continue the next part. And in this part, mainly we need the concept of properties of a triangle as well as whatever we have done in earlier part of this quadrilateral chapter. So today we start the new topic, which one is here already written. If you see, the Mid Point Theorem. So this one is very important. Later on we use this theorem, and with the help of this theorem we can solve each and every question. So now actually what is Mid Point Theorem and how can we relate this one with our quadrilateral chapter? So in this midpoint theorem, first of all, as you see here, we consider a triangle here, and the triangle is here, we consider ABC. This one is a triangle here. And in this triangle, what you have to do, you see, three sides are there, AB, BC and AC. And in this triangle, if we consider any two sides, it is not fixed that these two sides are we have to consider. You can choose AB, BC also. So inside AB, we consider a midpoint, and this midpoint is denoted by E, as well as we consider another midpoint, which one is on AC, and this one is we denoted by F. These two are the midpoint we consider. So obviously one thing we know, the length of AE and EB are equal because E is the midpoint, as well as the length of AF and FC are equal because F is the midpoint. So how can we apply the midpoint theorem here actually? In midpoint theorem, practically you can also do this one. So here, for example, we consider the length of this BC side. Just for an example, we consider this one. So here we consider 4 centimeter. And now here E and F are the two midpoints we consider, and the length of EF is here 2 centimeter. Is it clear? So now in this case, you see here what we get. What is actually midpoint theorem? If we consider any two midpoints on any two sides, the length of the midpoint side is half of the third side. That means whatever the length we get EF here, this EF length is obviously the half of the third side. That means BC. For that reason here written EF equal to half of BC. So for example, here we consider 4 centimeter and 2 centimeter. So if BC length is 4 centimeter, then EF equal to what? The half of this BC. So half of BC equal to how much? 2 centimeter. That's why here written. As well as one more property we get here. Angle AEF is always equivalent angle ABC. When it happen? When E and F are the midpoints. If E and F are the midpoints, the length of EF is half of the third side BC, as well as if EF are the midpoints, then angle AEF is equal to angle ABC. These two cases are always we get. Is it clear? One more property we know. If angle AEF is equal to angle ABC, that means these two angles are if equal. If these two angles are equal, then these two are also we can say corresponding angles, and EB we consider as a transversal. So if EB is we consider as a transversal, then these two angles are equal, corresponding angles. If these two angles are equal, then what we can say about these two lines? These two lines are always parallel. If corresponding angles are equal, then the opposite lines are always parallel. So that means here if you see, if EF equal to half of BC, This one is the midpoint condition, and angle AEF is equal to angle ABC if we get these two conditions. So from here easily we can say EF is parallel to BC. Is it clear? This one is the condition of midpoint theorem. So practically with the help of example we consider this one, and now here this one is the diagram. So now it related to this. Now if you see the theorem, so now here as you see the theorem here, the theorem is written: the line segment joining the midpoints of two sides of a triangle is parallel to the third side. As you see the figure, the line segment joining the midpoints of two sides, any two sides, it is not fixed that we have to consider these two sides, any two sides we consider of two sides of a triangle is always parallel to third side, because as you know already we have done EF equal to half of BC and angle AEF equal to angle ABC, then we get the sides are parallel, is not it? This one is the main theorem we need. Any diagram if we consider, if any two side midpoints are equivalent, then this side is always parallel to the third side. Is it clear? So with respect to this, now here one more theorem is there, and if you see this theorem, theorem 8.10. So the theorem is here: the line drawn through the midpoint of one side of a triangle parallel to another side bisect the third side. As you see the figure, here, and the figure is mentioned like in this way. If you see, first of all, in this diagram ABC we consider a triangle, and in this triangle we consider a midpoint E. You see in this figure, E is the midpoint, and through this E midpoint on the side AB, through this E midpoint we have to draw a line parallel to BC. When we draw a parallel line to BC through E, then obviously this line bisect the third side. That means the third side is AC and bisect at F. That means from here what we can say, F is also midpoint. Is it clear? So this one is the property. So that means these two theorems are totally opposite of each other. If we join two midpoints, then the sides are parallel, first point, and if the sides are parallel, then the line always passing through midpoint. So that's why 8.10 theorem is mentioned here: the line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Is it clear? Okay. Now after that, now if you see the example number 7 in page number 149 in your book, the example is given, and the example is given like in this way: in triangle ABC, D, E and F are respectively the midpoints of sides AB, BC and CA. As you see the figure mentioned, isn't it? So now in triangle ABC, D, E, F are the midpoints. So the side ABD is the midpoint, for side BC E is the midpoint, and for side AC F is the midpoint. Is it clear? So that the triangle ABC is divided into 4 congruent triangles. So that means here 4 congruent triangles means ADF, one triangle, another one is BDE, another triangle is DEF, and another triangle is FAC. These 4 triangles are congruent triangles we need to prove. So if you see the solution here already written as D and E are the midpoints. If you see, D and E are the midpoints of the side AB and BC of the triangle ABC. So in this case, if you see separately, if you forget this DF and FE, just you see DE. ABC is a triangle, D and E are the midpoints, so DE is always parallel to AC according to our midpoint theorem, is not it? If two midpoints are joined, then this line is always parallel to the third side. Similarly, we can say DF is parallel to BC as well as EF is parallel to AB, we can write. So from here, easily we can say ADEF. If you see the diagram properly, ADEF. Similarly, BDFE, if you see the figure, as well as if you see the figure here, DECF, all these three are parallelogram, isn't it? All these three are parallelogram. So just one example, if you see here, ADEF. In this ADEF, DF is what? The diagonal. That means these two triangles are what? Here, if DF is the triangle, then we get two triangles here. If DF is the diagonal, then two triangles we get ADF and DEF. So these two triangles are what? Obviously congruent. Similarly, BDE and DEF are congruent, as well as DEF and FAC, this one is congruent. Ultimately, all four triangles are here congruent. Is it clear? Very simple question. So, if you go through your book, then easily you can solve this one. Just we apply here which theorem? The midpoint theorem. With the help of midpoint theorem, we solve this one. So, today we discuss about the midpoint theorem, and the midpoint theorem is what? In a triangle, if we join any two midpoints on any two sides, then this joining line is always parallel to the third side, is not it? This one is the midpoint theorem, and with the help of this midpoint theorem, in our next class we have to continue the exercise 8.2. Is it clear? Okay, thank you.